All right, welcome to lesson 4 of Every Question Answered in the SAT Official College Board Blue Book. Right now, I am on test 2. This is the second test in the official Blue Book. What's awesome is that all the tests are available in PDF form online for free on the College Board website. So if you want to follow along with me, just head to the description and you'll have a link to the College Board website where every test is downloadable and the answer sheet is there and everything. So it's actually very nice of them to release that for free. My name is Alan. I'll be your instructor for today. And today we are on question 15, continuing and hopefully finishing up the math portion of test 2. So it might be not the full 2 hours as usual, but whatever it takes for us to finish the exam or test 2, we'll do that together. Feel free to write in the chat if you have any answers, if you have any questions, either one, post it in the chat. Don't worry about it if I see it or if your classmates see it. We're all kind of working through it together. And the answer is not as important as how to do the problem. So if you have any concern or you're really not sure how to do a problem, please, you're not going to bother me. Just write in the chat and I promise I will address your questions. All right. So yeah, let us jump right into it. Don't want to waste any more time. We're going to run down to question 15. The distance traveled by Earth in one orbit around the Sun is about 580 million miles. Earth makes one complete orbit around the Sun in 1 year. Of the following, which is the closest to the average speed of Earth in miles per hour as it orbits the Sun? So we know that it does 580 million miles per year. Okay, our job is to find out how many hours there are in a year, and then we'll just divide, right? Because miles per hour is just miles divided by hour. So if you've not written it this way, or if you have and you didn't realize, it's as simple as that. Miles per hour is just miles divided by hours. So we have the miles, we just need to find out what the hours are. So we know that in a year there are 365 days, and in each day there are 24 hours. So 365 times 24, let's go to the handy dandy calculator. What the? 3, how come it does double time? 3. Do you see that? Okay, let's try with the mouse. 365 times 24 is 8,760. Okay, so let's bring that down here. 8,760 hours. And now all we have to do is divide 580 million miles over 8,760 hours, and that'll give us the miles per hour. So let's go back and we'll do 580, 1, 2, 3, 4, 5, 6, divided by 8,760, and that gives us about 66,000. So A is our answer, 66,000 miles per hour. All right, moving on. Results of the bar exam, okay, of law school graduates, and we see these are the people that took the bar or passed the bar exam, and these are the people that did not pass the bar exam. All right. So the table above summarizes a result of 200 law school graduates. So that might be relevant. Let me just underline that. 200 total law school graduates who took the bar exam. If one of the surveyed graduates who passed the bar exam is chosen at random for an interview, what is the probability the person chosen did not take the review course? So we're dealing with probability. And with probability, you need to find out 2 things. The first is the sample size. Right? Out of how many are we choosing from? Okay, and that number usually goes into the denominator. So our total sample size, okay, so that'll be the denominator of our fraction. And the numerator is what we are looking for. So I would call it the our target sample. So actually, you know what? I'm going to erase that. I'll just say target. So who are we targeting over the sample size? So let's start with the sample size. if one of the surveyed graduates who passed the bar exam is chosen at random. So how many people passed the bar exam, right? That's our sample size, because those are the people who were interviewed. So we see these are the people that passed the bar exam. So our sample size is going to be out of 25. And so out of the people who passed the bar exam, what is the probability that the person chosen did not take the review course? So this is our sample size, and now what's our target? The target is the people who did not take the review course. So in this case, 7 people did not take the review course, and hence our probability is 7 out of 25. Perfect. B. Let us move on. The atomic weight of an unknown element in atomic mass units is approximately 20% less than that of calcium. The atomic weight of calcium is 40 AMUs. Which of the following best approximates an atomic weight in AMU of the unknown element? Okay, so all we have to do is find out what is 20% less than 40 AMUs. And if you recall in the last session when we were talking about percent less than or more than, really what you're trying to find out is what is the percent of the source? Where are we coming from? In this case, we're going from 40 down, right? So we want to find out what is 20% of 40. And once we know that, we want to then subtract that from 40. Okay? So what is 20% of 40? And like all or most percent of problems, we just want to translate 2 things. The first is we want to translate this into a decimal. And the way that we do that is we move the decimal point to the left twice. Okay, so we move the decimal place to the left twice. So 20% becomes 0.20 or 0.2, they're equivalent, of, we can translate, and that's the second thing we need to translate. We translate of to mean multiplication. So whenever you see of in a percent problem, you can translate that to mean multiplication. So 0.2 times 40. So once we know that, this should be pretty easy to do on our handy dandy calculator. So we'll do 0.2 times 40, and we'll get 8. Okay, and now once we get 8, we now want to subtract that from the source. And what's our source? Our source is 40 AMUs. So 40 minus 8, and we'll get C, 32. Very nice. All right, and if you have any bonus questions about how do you do percentages, how do you find percent of, how do you do percent more or less, ask in the chat, or if you're watching this at a later time, just write in the comments, and I will be glad to come back and answer your questions. All righty, number 18. A survey was taken of the value of homes in a county, and it was found that the mean home value was $165,000. And the median was $125,000. Which of the following situations could explain the difference between mean and median home values in the county? Well, I'm not even going to read the answer choices for now. Let's just think about this logically. So the median, right? What is a median? It is when you organize a list of numbers, right? Let's say 1, 1, 2, 2, 5, 6. Okay. Let's just put 7 here. The median is the number that's directly in the middle, right? If you organize it from smallest to greatest. The mean, as we know, is when you average all of the numbers. And then so you add up all the numbers and then you divide it by how many values you have. Okay, so what could make a mean much higher than a median? Right, well, let's say first of all, in this case, right, if we added another 1 to the front and then added a 10,000 at the end, would our median change? Probably not, right? Our median is still 2, it's the middle number, but we just added a huge number. We added 10,000. So that means if we average out these numbers, right, we're gonna see a much higher mean, right? A much higher average as compared to the median. So what I think in this problem, why the house price is so why the average price is so high compared to the median? That's because there's probably somebody really rich who has a huge mansion and everybody else kind of has smaller homes. So we want to find out where C, there are a few homes that are valued much more than the rest, right? And so that's like our example where one home is 10,000 and all the other ones are kind of 1, 1, 2, 2, 5, 6, 7. All right. And I see we have Ashvath Vijay asking in the chat, our new subscriber, so thank you for subscribing. Which section are we doing right now? We are doing section, let's see, let me scroll up. So we're doing section 4 in practice test 2, right? So in the 2018 book, we are doing section 4 of test 2. And this is the calculator section. And if you want to follow along with us, the link to the College Board PDFs are in the description. All right, so I remember doing these problems, and I really like this one. I think it's a little bit trickier than it seems, but I think it's the perfect problem for really understanding what a median is, okay? Median and mean. So let's go through this. A sociologist chose 300 students at random from each of the 2 schools and asked each student how many siblings he or she has. The results are shown in the table below. All right, and we see how many siblings they have from 0 to 4, and then each of the schools, how many students answered, either 0, 1, 2, or 3, or 4, okay? And please note here, they kind of snuck this in the bottom, but there are 2,400 students at Lincoln and 3,300 students at Washington. This will come back in a little bit, okay? So if you see these little blurbs, do not just skip past these. Make sure you read every single part of the question. You don't want to miss any of it. So number 19, what is the median number of siblings for all the students surveyed? So wow, let's think about this, right? We need to find all of these numbers. Look, imagine there are a bunch of zeros that people answered, right? A bunch of zeros. Then there are a bunch of 1s, then there are a bunch of 2s, so on and so forth, 3s, 4, right? And there are a lot. I just wrote a few. We need to find out what is that middle number. What's that middle number going to be? How are we going to figure out what that middle number is? Well, the big hint here is that we know there are 300 students in total, right? So if you calculate all of the numbers lined up, it's going to be 300. So our goal is to find out, right, which number, and actually, wait a minute, it's 300 students from each of the 2 schools. So I'm sorry. So that's my mistake. It's not 300. It's going to be 600 in total, okay? Our job is to find out what is going to be that 300 and 301st value, right? Because the median is going to be right in between them, okay? So we know that there are a bunch of zeros, a bunch of 1s, a bunch of 2s, right? But how many zeros are there? Let's see, right? We see there are 120 zeros from Lincoln and 140 zeros at Washington. So we know that zeros, there's going to be 260, right? 120 plus 140, there's going to be 260 zeros, okay? Then there are going to be 190 ones. Well, if you see this, right, the 300 and the 301st number are going to come in this 1 zone, right? Because there's going to be 260 zeros. Imagine those in a row. Then we're going to have 40 ones, and then we're going to have 150 more ones. So the 300 and the 301st numbers are both going to be 1. Hence, the median will also be 1. Okay? So take a few moments to kind of settle that in your brain a bit, right? It took me like a few seconds to register that, but just understand there are 600 numbers in a row, and then our goal to find the median is to find the exact middle number, right? So there's going to be 260 zeros, then there's going to be 190 ones, right? So the 300 and 301st number are both going to be 1s. So that means our median will be 1 for this problem. All right. If you have any more questions, just ask me in the comments, but I like this problem a lot. All right, based on the survey data, which of the following most accurately compares the expected total number of students with 4 siblings at the 2 schools? Aha. So how many siblings do we expect to be at Lincoln, and how many do we expect to be at Washington? Well, I see that at Lincoln, right, there are 10 students out of, so let me actually write that here, right? At Lincoln, there are 10 students that answered out of 300, okay? So that means that 1 out of 30 students we expect among the total population of Lincoln to have 4 siblings, right? We can kind of extrapolate that. So if 1 out of 30 of all the students at Lincoln have 4 siblings, then we could just do 1 out of 30 times 2,400 at Lincoln, okay? And what is 1 over 30 times 2,400? That's going to be 2,400 over 30, and I believe that's going to be 800. Am I crazy? Yes, I'm crazy because it's actually going to be 80. Okay? 2,400 divided by 30 is 80. And my brain might not be working, so I'm just going to confirm that. 2,400 divided by 30, okay, is 80. I'm not losing my mind. We're all good. Okay, so that's how many students we expect at Lincoln. What about at Washington? Well, at Washington, we also see that there are 10 out of 300 students, okay, who answer that they have 4 siblings. So we can assume that in the entire school, there are also 1 out of 30 students who have 4 siblings. So 1 out of 30 times 3,300, okay, that's going to be 3,300 over 30. And I know this, okay, this is a little bit easier. This is 110. Okay, so we expect 110 students at Washington to have 4 siblings. So in our case, I believe the answer is C. The total number of students with 4 siblings at Washington is expected to be 30 more than at Lincoln. All right. Number 21. A project manager estimates that a project will take X hours to complete, where X is greater than 100. The goal is for the estimate to be within 10 hours of the time it will actually take to complete the project. If the manager meets the goal and it takes Y hours to complete the project, which of the following inequalities represents the relationship between the estimated time and the actual completion time? Okay, so X is our so X is our estimation, right? X is our estimation, and it's greater than 100. Okay, so we want to maybe choose our own numbers. I always recommend choosing your own numbers when you can. So what's the number that we can choose for X? Well, let's say X is greater than 100. Let's say X is equal to 110. Okay, and Y is the actual time that it takes to complete the project. So Y, and we know that it has to be within 10 hours. So let's say it took about 5 hours longer than expected. So Y is equal to 115. Right? So these are 2 numbers that we picked for X and Y that could be realistic. So let's see which one of these 4 choices actually works for these numbers. A, X plus Y is less than 10. We know that's not true. These are pretty big numbers. Y is greater than X plus 10. So is 115 greater than 110 plus 10? No, it's not. So B is out. Y is less than X minus 10. So is 115 less than 110 minus 10? Is 115 less than 100? That is not true. Okay, so D is pretty much our only answer left. So let's just make sure that's right. So 115 minus 110 is 5. So is 5 between 10 and negative 10? It is. Right, but we could have chosen different numbers that maybe C would have worked for and D would have as well. So when you're choosing your own numbers, try to maybe pick 2 different situations. Usually one of those 2 situations will break when testing for both, and the right answer will be clear right away. Okay, so in our case, we got a little lucky. We chose really good numbers, but I would say in your case, it would have been just as easy even if you picked something else. All right, moving on to 22. Let me get a little water here so my voice doesn't get hoarse. All right. So if you're new to the channel, by the way, I saw that we have some people in the chat who already subscribed. Thank you very much. One quick benefit of subscribing is that I might be doing some early streams. And that will pretty much be unannounced. So if you're a subscriber, you get an email right away saying, oh, Allen Mentoring just went online. And that'll give you a really good opportunity to answer or ask questions basically one-on-one. You know, there won't be that many people in the stream, so that's one little benefit of hitting that subscribe button. What's our goal at? Our goal is 20 subs for the month, and we're at 12, so we're doing pretty well. We still got, what's today's date? The 18th. So we still got about 13 days to go, about half the month. So I think we can get that number up to 20. Tell all your homies about the Allen Mentoring SAT stream. All right, enough marketing. We're going to number 22. So we see we have a formula here for intensity I, and that's related to P over, which is power, 4 pi r squared. Okay, and r is a large distance from a radio antenna. Okay, I'm feeling that. Which of the following expresses the square of the distance from the radio antenna in terms of the intensity of the radio signal and the power of the signal? So those are a lot of words that are kind of tricky, but if you see the answer choices, all they really want you to do is isolate r squared. So put r squared on one side and put everything else on the other side. And so we've seen a ton of these problems, so we should be very familiar with how to do this. Okay? And just like any algebra problem, what we want to do is the opposite to both sides. So in our case, let me just rewrite this. I is equal to P over 4 pi r squared. So the first thing is we want to get this r squared out of the denominator, right? And so if r squared is kind of dividing P, the way that we get it to the other side is we do the opposite. So we multiply r squared on both sides, okay? And the magic of doing that is that r squared over r squared cancel out. And so now we have r squared I is equal to P over 4 pi. Okay, so we're almost done here. How do we isolate r squared, right? We want to get rid of this I. This I is in its way, right? We want to just have r squared. So what do? The opposite to both sides, right? Instead of multiplying I, we want to divide I on both sides, right? We're going to divide I on both sides. On the left side, it'll cancel out. And on the right side, if there's a fraction and we're dividing another variable, you kind of just can attach it to the denominator. So in this case, r squared is equal to P over 4 pi I. Okay, you see how when we divide I, we take this fraction and we divide it by I, we can just kind of attach it to the denominator. All right, so which of these choices looks like this? I believe it's B. All right, pretty good, pretty good. 23. For the same signal emitted by radio antenna, observer A measures its intensity to be 16 times the intensity measured by observer B. The distance of observer A from the radio signal, from the radio antenna, is what fraction of the distance of observer B from the radio antenna? So basically, right, we want to see which, we want to set up both observer A and observer B by using the formula that they gave us, okay? And so we see that the intensity, okay, so the intensity of A, or the intensity of person A, is equal to 16 times the intensity of observer B, okay? But what we want to know is what is the distance of observer B from the radio antenna, or what the distance of observer A is what fraction of the distance of observer B, okay? So what I want you to note here is that really the only difference between the two is how far they are, okay? Nothing else is really changing, right? The only difference is how far they are. So if we saw in this step right here, right, when we multiplied r squared times I, we see that r squared times observer A is basically 16 times observer B times r squared. Nothing else really matters except the distance of the radio tower. Okay, and I want you to kind of see that. The power is the same, everything's basically the same. Okay, and so if it's a square inverse function, okay, then we see, or here it says, the intensity is related to Where did it say that? Oh yeah, here it is. The square of the radius distance from the radian. Okay, right, we see that they're inversely squarely related. Okay, so if this is 16 times as intense, okay, then the distance must be 1/4. It is inversely, aka 1 over 16, and it's related by a square function. Right, so if it's 1/16 and it's squared, then the square root of that will be equal to 1/4. All right, so it's an inverse square relationship, hence the distance must be 1/4. Okay, if you have any questions, please let me know in the chat or in the comments below, and I will address them. All right, numero 24. The equation of a circle in the xy plane is shown above. What is the radius of a circle? And this is pretty much something we come back to almost every single test. So I highly recommend memorizing and knowing well the equation of a circle. Okay? So what is the equation of a circle? Standard form is x minus h squared plus y minus k squared is equal to r squared. Okay? So what do all these things mean? HK, okay, is the xy coordinate of the center. Okay, the very center of the circle. All right, so if it was x minus 2 squared and y minus 3 squared, then the center would be 2, 3. All right, r squared, r is equal to the radius. I see Ashvath has a question about 23. I will answer that. We're going to have a little break coming up in a little bit, and I will answer your question when we hit the break. But thank you for asking. Probably, I would say within about 4 questions, we're going to hit the break. So stick around, and I promise we'll answer that. Okay. So in our case, how do we find out what the radius of the circle is? Right? We can't just say, oh, wait, so it's -1, right? That must be like r squared, so the radius is the square root of -1. No, right? Because for us to know what the radius is in this form, we have to put it into standard form. And we see here, this is definitely not standard form, right? It does not look like what we have here. And so let me first maybe rearrange this to get it close to standard form, right? So let's kind of bunch the x's together and the y's together. So I'm just going to rewrite the equation as such. X squared plus 4x, okay, plus y squared minus 2y is equal to -1. Okay, so now it's kind of closer to this form, but yet they're still not, we don't see any parentheses, right? How do we now take these guys, all right, and put them into their squared forms, right? How do we complete the squares? And so that is a technique that's very famous. I'm sure you've heard of it before, completing the square. And completing the square is basically adding a magic number to both this side and this side such that you'll have a perfect square in here, and then you can kind of convert it to this form. Okay, and you'll see what I mean. Right, so how do you find out what is that magic number that you add to both sides? So that magic number, all right, and I'll call it the magic number, M number, okay, is equal to the B term, right? And so the B term will be the one next to the X, and it'll be the one next to the Y, okay? So the B term over 2 squared, okay? So that is the formula for the magic number. All right, and we can get into why that's the form in a little bit later if you're interested. But for now, just know that half of the B term squared will get you that magic number. So what is half of the B term squared? Well, in here, half of 4 is 2. Squared will be 4. Okay, so we want to add 4 on this side and 4 on this side. Okay, and remember, whatever we do to the left side, we have to do to the right side. You have to, okay? So what is going to be the magic number in this case? So the B term is equal to -2. What's half of -2? That's 1. And what is 1 squared? Or sorry, -1 squared? That's going to be +1. So we're going to add 1 to here, and we're going to also add 1 to here. So now if I was to rewrite this, I would have x squared plus 4x plus 4 plus y squared minus 2y plus 1 is equal to negative 1 plus 4 plus 1. So that's going to be equal to 4. And so this is actually a lot more work than this problem requires, but I just want to kind of take it to that full end, just so you really understand how completing the square helps you solve circle problems. Okay, so this is a very valuable lesson if you haven't seen this before. So I suggest you kind of follow along with me. And so now that you have it in these parentheses, right, how do you convert it to this form right here? So we see here, by adding that magic number, we can take the square root of this and we can say that this is equal to x plus 2 squared. Okay, and if you FOIL this, I promise x plus 2 squared will get you x squared plus 4x plus 4. We see that this can be square rooted into y minus 1 squared, okay, because we're trying to multiply to positive 1 and add to negative 2. So the square root of this will be y minus 1. And now it's equal to 4. So do you see how we converted this form right here into our standard circle form right there? Okay? And so now we see that r squared is equal to 4, and so our radius must be equal to 2, right? Because 4 is equal to r squared, so r will be equal to 2. All right? So yeah, try that problem yourself just to make sure you have the same answer, but we should be good to continue. All right, 25. The graph of the linear function f has intercepts at a comma 0 and 0 comma b in the xy plane. Okay, so maybe it'll be wise for me to draw like a little xy plane here, kind of like that. Okay. If a plus b is equal to 0 and a is not equal to b, which of the following is true about the slope of the graph f? Okay, so let's see. A comma 0 and 0 comma b, and we know that combined they have to be 0. So let's draw some examples, right? What could a be and what could b be? Well, if a and b equal to 0, if a is equal to 2, then b must be equal to negative 2. Okay, so what would then the points look like? Well, we would have 2, 0, which would be, let's say, somewhere like here. And then we would have 0, negative 2. And so that would be somewhere like right there. So then what would the slope between these 2 points look like? Right, what would the slope between these 2 points look like? Right? How do you find out what the slope of a line is? Is it positive or negative or 0? Right? I want you to read the slope like you would a book. How do you read a book? You read it from left to right. And from left to right, this slope is going up. And if the slope is going up from left to right, we know that A, it is positive. Okay? If the slope was going, let's say, like this, right? From left to right, it's going down. You see that? From left to right, it's going down. So this slope would be negative. Okay? A horizontal slope like this is 0. And then a vertical slope like this is undefined. A perfectly vertical slope is undefined. So that's something for you to remember. But if you remember nothing else from this, left to right, read it like a book. 26. The complete graph of the function f is shown in the xy plane above. Which of the following are equal to 1? So what is equal to 1? So if you see function problems like this, usually the number, or actually always, the number inside the parentheses refers to the x coordinate, okay? So f of negative 4, we look for where is x negative 4, right? X, it's f of x, right? F of x. So where is x negative 4? Negative 1, 2, 3, 4, right here. And so what is f of negative 4? Where is the y coordinate at negative 4? It is at 1. Okay, we see that. So f of negative 4 is equal to 1. So that is Good. Okay. What about f of 3 halves? So what 3 halves is, oops. 3 halves is right here, right? X is 3 halves right there. And so then we look at the y, and the y is 1 right there, right? So this works. So 1 and 2 work. So that's not it. That's not it. That's not it. 1, 2, and 3. All right, and just for fun, f of 3 we see is right there, right? X is 3 right here. And so y is also equal to 1 at that point. Okay? Geez Louise, it's a lot of words for this next problem. Okay. Let's try to get through this, guys. Don't panic. If you see a problem that's really long like this, maybe you can skip it and then move on and come back to it later, right? You don't want to waste time taking 5 minutes to read a problem when, let's say, for example, the next problem could be done in like 20 seconds. Okay, so that's a little bit of a pro tip. If you see a giant, long, wordy problem like this, and if you're a slow reader especially, don't worry about it. Skip it for now, do the rest of the test, and come back to it later. But never leave anything blank, obviously. So, okay, 2 samples of water of equal mass are heated to 60 degrees Celsius. 1 sample is poured into an insulated container, which are these squares. The other sample is poured into a non-insulated container, which are the circles. The samples are then left for 70 minutes to cool in a room that's 25 degrees. The graph shows the temperatures of each sample at 10-minute intervals. Which of the following statements correctly compares the average rates at which the temperatures of the 2 samples change? Okay, so compares the average rate of change. So they're basically saying, and every 10 minutes, like look, for the non-insulated, right? For the circles, we see from 0 to 10 minutes, it goes from about 60 to 42 or so, right? So the rate of change there was about -8 or 18, -18. That's what I said. Okay. Then we see from 10 to 20, it goes down from like 42 to 33. Right, so it's about like -9. All right, and then so we see the squares are a bit more even, right? They kind of dip a little bit to start, okay, and they slowly get cooler and cooler, okay, whereas the non-insulated, right away, they get super cool, and then they kind of stay at their coolness. So let's look at this. How do we compare the two? So I would say that maybe the insulated is slower in the beginning, right? Because it kind of goes a little bit down, but it kind of goes down the entire time, whereas the circles are really super fast, right? High rate of change in the beginning, but then it kind of goes really almost nothing towards the end, right? So that's where I want to find. So A, in every 10-minute interval, the magnitude of the rate of change of temperature of the insulated is greater than that of the non-insulated. That's not true, right? Because we see in the beginning, the non-insulated goes much, much faster down. B, in every 10 minutes, the magnitude of the other one is greater. So that's not true also, right? At every point, it's not always greater. So this is what we're looking for here. In the intervals from 0 to 10 and from 10 to 20, the rates of change of temperatures of the insulated sample are of greater magnitude, whereas in the intervals from 40 to 50 minutes and 50 to 60, the rates of change of the temperatures of the non-insulated are of greater. So that's actually not true. It's the opposite. At the end, the insulated has a greater rate of change. So that's out. So D must be the correct answer. Okay. All right. So at this point, we're about 40 minutes in, and we have, let's see how many questions left. 38 total. And we are at question 20. All right, so we have about 11 questions to go. So I think it's a good time to take about a 5-minute break. Do not go anywhere. I'm going to come right back. And the first thing I'm going to do is address Ashfath's question about number 23. I would say a pretty tricky problem overall, but we will definitely go into that. And then I see you also posted another problem from Khan Academy, and it's about system of equations. And I love system of equations. I think they're very important for the SATs. They ask a ton of system of equations problem. So I will answer your question on stream for sure. All right, so stick with me. I'm going to grab some more water, obviously. Okay. And I will be back in a jiffy. So let me see, let me actually post. 1 second. I'm going to put a 5-minute timer on screen. We're about to do some stream magic here. So we're going to take this. We're going to get that out of here. We're going to put this on. We're going to, bam, take that off. Yeah, we got some stream magic. Okay, take that off. Put this right here. Put that right there. Okay, that looks good. All right, so when that hits 0, I will be right back with you. All right. Yes, back just in time. All right. No! I messed everything up. No! I didn't realize this was gonna kill my entire... Oh, man. Alright, sorry guys. I need to fix this just really quickly. I don't think this is gonna ruin my first screen. Okay, that looks good. Hope you guys forgive me for this waste of time. All right, while I do this, I can also look at Mr. BJ's problem. A is minus 1.4 is equal to C. Okay. So that's a pretty standard system of equations problem. The only tricky part is that it uses decimals. Okay, so we should be good, I think. Hope you guys could see everything well. Let me know if you can't. All right, so first things first, I do want to address, where'd my little, which one of y'all took my pen? All right, so I want to address number 23 because I don't feel comfortable with the way I explained it. I think I maybe rushed a few steps. So let us start from the very beginning. Okay, all we know is that observer A compared to observer B, right? There's a 16 times as intense or 60 times as high intensity of observer B as A. Okay, so we get that part, I hope. All right, and so the next step is let's replace both of these with the original equation. And so I'll show you what I mean by everything else cancels out. So how do we replace the intensity for A? I'll just use this original equation. So P over 4 pi r squared equals 16 times P over 4 pi r squared. And what I want to note is, remember, these r's are not the same. They're at different distances, right? So we just want to remember to label this one as RA and this one as RB. Okay? So how do we solve RA for RB? Okay, how do we do that? Well, first of all, right, we see that there are lots of things on both sides, right? There are lots of similar things on both sides. This P is the exact same value of this P, right? So what we could do is we can cancel this out, right? Divide by P on both sides, so that cancels out, right? We could also multiply 4 pi on both sides, okay? And have this cancel out. All right, so if you have the same exact values on both sides, you can cancel both of those out. So what are we left with? All right, if I rewrite this, we see that 1 over r squared, okay? So the r squared of observer A is equal to 16 times, all right, 1 over r squared of observer B. All right, so we're cool with that so far, okay? So that's kind of what I meant when I wrote this out, but it might have not been clear. And so now, lastly, right, we want to get rid of these fractions. So what we can do is we can multiply RB squared on both sides here. Okay? On both sides, this cancels out. Okay, and then we could also multiply r squared A on both sides to get rid of this r squared. Okay, so we're multiplying r squared a on both sides. So if I rewrite that, I get r of b squared is equal to 16 r of a squared. Okay, and so now clearly here we have an inverse, a squared inverse relationship. Okay, so if you want to just solve for RA, what you can do is you could square root both sides and have RB is equal to 4RA, and then isolating R of A, okay, so the radius of the observer A, we would just divide on 4 on both sides. Okay, and so RA is then equal to 1/4 R of B. So I hope that's much more clear. I'm sorry that I didn't go into as much detail in the original time, but I hope this is a little bit clearer, right? And so you see how P, R, and pi did not matter at all for these problems because they're the same for both. All right, so I hope, Ashvath, that helped you a little bit. And I promise I will get to your Khan Academy system of equations problem as the last problem of this test. So if you could stick with me until question 38, there's only 11 more to go, then I promise that will be the first viewer question I answer. So number 28. In the xy plane above, ABCD is a square, and point E is the center of the square. Gotcha. The coordinate of points C and E, okay, are 7, 2, and 1, 0 respectively. So this is 7, 2, and this is 1, 0. Okay, we're good. All right. Which of the following is an equation of the line that passes through points B and D? So we want to find out what is the equation of this line. That was a really bad line. Of that line right there. All right, what is the equation of that line right there? So what do we need to find out the equation of a line? Well, we need two things, right? We need a slope, all right, especially in the point slope form, right? We want a slope, which is represented by m, okay? So we need a slope, and we need an xy coordinate in that line, right? So we need any point that line goes through. If we know both of those things, then we can pretty much get the equation of any line we want. So in our case, we actually have one of those two things, right? We have one of the points that it goes through because we know that the diagonals intersect at the center. So we know that one of those points is 1, 0. All right, so we have that. So really all we need to know is the equation, or is the slope of this line right here, and we should be pretty much good to go. So how do we find out what the slope is of this line? Well, look at our hint, right? They give us 2 points on this other diagonal. And what do you know about the diagonals of a square? They are perpendicular, right? So the diagonals of a square, all right, they make a right angle with each other. So all we need to do is find out what is the slope of AC, and then we'll find the perpendicular slope to that one, okay? So how do you find the slope of AC? Well, we have 2 points, 1, 0 and 7, 2. How do you find the slope between 1, 0 and 7, 2? We do the difference of the y's divided by the difference of the x's. So what is 2 minus 0? Okay, over 2 minus 0 over 7 minus 1. So that's going to be equal to 2 over 6, which is 1/3. So the slope of AC is 1/3. What is the slope of BD? To find the slope of a perpendicular line, what you need to do is get the negative reciprocal of your original line. So what is the negative reciprocal of 1/3? Well, negative of 1/3 will just be negative 1/3, and the reciprocal just flips it over. So the perpendicular line, okay, of 1/3 will be equal to negative 3 over 1, which is just equal to negative 3. So now we have the other piece of the puzzle. We see that the slope is negative 3, and the line goes through 1, 0. Okay, so how do we put that into y equals mx plus b form? You could do it a few different ways. Maybe the best way would be using point slope first. So point slope is y minus y1 is equal to m times x minus x1. Okay, and all we have to do is fill in x1, y1, and m. And so y minus 0, right, because that's our y coordinate, is equal to m, which is negative 3, times x minus 1. And if we solve that, okay, I'm going to solve that right there. Y is equal, actually, it's right here, right? Negative 3 times x minus 1. Bam. Okay, if you wanted to distribute negative 3, you can get negative 3x plus 3. Okay, so that is the slope of our other diagonal. Number 29. In the system equations above, a and b are constants. For which of the following values of a and b does the system of equations have exactly 2 real solutions? So I can tell that this problem we will probably want to guess and check, and in a good way, right? Because they give us the choices and they ask us which of the following will work for blah, blah, blah. So in this case, I feel confident that guessing and checking is one of the better strategies to use. So before we do that, right, we want to put in a value here for y. So we see y is equal to 3 and y is equal to ax squared plus b. Right, so we can just replace this y right here with 3 because we know that's equal to 3. So we can say 3 is equal to ax squared plus b. Okay, and so now it's asking us for which of the following values of a and b the system of equations have exactly 2 real solutions. All right, and so we'll see what they mean in just a second. Let's say we try out a, negative 2 and 2, right, and we plug that in. So 3 is equal to negative 2x squared plus 2. All right, so now if we solve for x squared, we would subtract 2 on both sides. Okay, and then we would have 1 is equal to negative 2x squared. And then we would isolate x squared by dividing negative 2. Okay, these would cancel out. And so x squared is equal to negative 1/2. Well, that's an issue, right? How could x squared be equal to a negative number? Nothing, no real number squared can ever be negative, right? So the answers here are not real. They're what's called imaginary, okay? They're imaginary numbers. So in this case, A is incorrect. So now our goal is to find out which of these values will x squared be positive. Because if x squared is positive, we know that there are 2 real solutions. So negative 2 and 4, would that work? 3 is equal to, we'll just do this really quickly, negative 2x squared plus 4, subtract 4 on both sides, negative 1 is equal to negative 2x squared, divide negative 2, divide negative 2, super fast, x squared is equal to positive 1/2, and so then x is equal to 2, has 2 real solutions, okay? And what are the 2 real solutions? They are equal to positive square root 1/2 and negative square root 1/2, okay? Because we are square rooting both sides. All right, so I hope that made sense. And I think if you try out the other numbers, they will all get you negative solutions, okay? They'll get you imaginary number solutions. All right, number 30. And for this one, I remember I have to go way back in the memory bank. All right, so I'm gonna give you a little recommendation about this one. So let's see what this is. The figure above shows a regular hexagon with sides of length A and a square with sides of length A. Right, so everything here is A. Okay. If the area of the hexagon is 384 root 3, what is the area of the square? Right, so pretty much our goal, if we can find out what one of these A's are, then we would that'd be easy to find out the area of a square is, right? So how do we find out what each of these side lengths are of a hexagon based on its area? And so for that, that's what I really had to go back to the memory bank for, like early high school. I don't know if your geometry teacher told you this, but it's very, very useful. It's the area of a regular hexagon. And so the area of a regular hexagon, okay, and that is a hexagon with all equal sides, okay, the area for that is 3 root 3 over 2 times s squared. All right, so that's a very tricky formula, but if you do have time to make a few flashcards, one of the flashcards should have the equation of a circle. I highly recommend that. Another one probably should have this area of a hexagon. You don't know if it when it comes up, it might, and it's very wise for you to have that. So in our case, we know that the area is equal, and so our s squared, I could just rewrite this as a squared, right? Because a is each of the sides. So in our case, the area is equal to 384 root 3. So how do we solve for a in this case? All right, well, first thing we want to do is divide root 3 on both sides. We see that root 3 exists on both sides. Okay, so we're going to divide this side by root 3, and then we could just cancel these out on both sides. Okay, and so now we have 3 halves times a squared is equal to 384. We see we have a division of 2 here, right? We're dividing by 2. So what's the opposite of that? We're going to multiply by 2. Okay, so 2 divided by 2 cancels out. So 3a squared is equal to, what's 384 times 2? 3. Don't want to make any simple mistakes here. 384 times 2 is 768. Okay, and we're going to divide that by 3. So a squared is equal to, divide that by 3, 256. All right, and actually that's all we need to do, right? Because we know that a times a is the area of the square, and so a squared is equal to 256. So look at that, we didn't even have to solve for what a is in this problem. All right. Okay, so now we're approaching the end. We're in the short answer portion. And if you recall, the questions get really easy in the beginning of the short answer. They get easy. They start easy in the multiple choice, then they get harder, harder. And then once you get to the short answer, they get really easy again and get harder, harder. Okay, so let's say, for example, you forgot what the hexagon area formula is. I suggest you skip this problem, go to the short answer portion, do all of those easy problems, and then come back to the multiple choice section, right? You want to maximize your points. That's your goal, right? You don't want to waste time on problems that might be really difficult when that time is being taken away from really easy problems. Okay, so keep that in mind as you do this test. So 31, a coastal geologist estimates that a certain country's beaches are eroding at a rate of 1.5 feet per year. According to the geologist's estimate, how long will it take in years for the country's beaches to erode by 21 feet? So this is a pretty easy one. If it's 1.5 feet every year, how many years will it take to get to 21 feet? So we would just do 21 divided by 1.5. I'm going to use my calculator because, again, I don't want to make any stupid mistakes on the calculator portion. And so 21 divided by 1.5 is 14. Very nice. If h hours and 30 minutes is equal to 450 minutes, what is the value of h? So it's h hours and 30 minutes. Okay, so the first thing we probably want to do is subtract those 30 minutes from 450. And we get 420. And so how many hours is in 420 minutes? Well, in each hour, it's 60 minutes. So 420 divided by 60 is equal to 7. So 7 hours. Pretty easy so far. 33. In the xy plane, the point 36 lies on the graph of the function 3x squared minus bx plus 12. What is the value of b? Well, they're very kind to give us an x and a y coordinate. So whenever you see an x and a y coordinate and an equation, I want you to think, how can I plug in these x and y values for x and y's that you see in your equation. Well, I only see x's. Where's the y located? Well, f of x right here can also be substituted to mean y, okay? Y and f of x, when you're talking about graphs, are interchangeable, okay? So the y-axis or the f of x axis, pretty much the same thing. So let me now plug this in. So 6, right, because 6 is our y value, is equal to 3 times 3 squared, and I plugged in 3 for x, minus b times 3 plus 12. So now this became a pretty easy linear algebra problem, right? So 3 times 3 is 9, times 3 is 27, minus 3b plus 12 is equal to 6. Let's not make any stupid mistakes, okay? We see that 27 plus 12 is 39, okay? So 39, 6, subtract 39 on both sides. What is 6 minus 39? That's going to be negative 33 is equal to negative 3b. Last step is we want to divide by negative 3 on both sides. And so we get b is equal to positive 11. All right, 34. Only 5 problems left. In one semester, Doug and Laura spent a combined 250 hours in the tutoring lab. Good on them. If Doug spent 40 more hours than Laura did, how many hours did Laura spend in the lab? So these are pretty popular problems. Sometimes they do it with ages. If Dave is 10 years older than Mark, now how old will he be in like 10 years or so? So these are pretty much done the same way. We want to set x to be the lower person's value. So it's easier. You could do it either way, but I suggest setting x to the lower person's, the person with the least amount of hours, or the youngest person, whoever has the lowest number in that problem. So in our case, Doug spent 40 more hours than Laura did, so Laura's going to have a lower number. So we're going to set x to be Laura's hours. Okay, and if x is Laura's hours, what are Doug's hours? That's going to be x plus 40, right? Whatever she did plus 40 will equal Doug's hours. And combined, x plus 40, right, together, they worked 250 hours. Okay, so how do we solve for x? Combine like terms. X plus x is 2x plus 40 is equal to 250. 2x is equal, we're going to subtract by 40 on both sides. Okay, 2x is equal to 210. And then we're going to divide by 2 on both sides. Again, we're doing the opposite on both sides. So I'm starting to go a little bit faster now. If you followed earlier in the stream, I kind of explained some basic algebra principles, but now we're just going to up the speed. And so x is equal to 105. Okay, so how many hours did Laura work? 105 hours, right? And she is represented by x. Very nice. All right, 35. A is equal to 18t plus 15. Okay. Jane made an initial deposit to a saving account. Each week thereafter, she deposited a fixed amount to the account. The equation above models the amount A in dollars that Jane deposited after T weekly deposits. According to the model, how many dollars was Jane's initial deposit? So let's understand what all these numbers mean. A is all the money that Jane has deposited, okay, all of the money. T is how many weekly deposits she makes. So what does 18T mean? That means that every week she deposits $18, right? 18 times 1 week, 18 times 2 weeks, 18 times 3 weeks. So what is 15? Why are you adding a random 15 to this equation, right? 15 is kind of our y-intercept, aka the starting amount, right? We're adding 15 because that is what she started with, plus 18 times however many weeks she's been depositing. So in our case, 15 is the initial deposit. Okay, and if this was graphed, and a lot of times you'll see these problems in graph form, okay, a lot of times that is not what I meant to do. Why does that keep happening? All right, let me try this. Okay. All right, if you see this in graph form, chances are, right, the graph will look something like that, okay? And right here, you'll see that this value is 15, right? Because she's starting with 15 and the line is going up like that. All right, 36. I love actually these circle problems with minor major arcs because once you do a few of them and you understand the basic principles, they're really easy. So you should be happy when you see one of these problems on the SATs because they're pretty much easy points. So in the figure above, point O is the center of a circle. Line segments L and M, or LM and MN, so these lines, are tangent to the circle at these points right here. Okay, so we know if they're tangent, they make a 90-degree angle with the radius at that point. Right, the radius is here, the radius is here, it's 90 degrees. If the circumference of the circle is 96, all right, so the circumference is equal to 96. What is the length of this minor arc, Ln? Okay. So in order for us to find out what the minor arc length is, we need to find out what is the measure in degrees, right? How many degrees is this minor arc? And our hint here is that the minor arc, or this arc right here, is equal to the measure of this central angle. So the central angle and its intercepting arc are always equal. So how do we find out what the measure of the central angle is? Well, we see that we have a quadrilateral here, right? LMNO is a quadrilateral, 4 sides. And so what are all of the degree measures in a quadrilateral, right? That's 360 degrees in total. So we see that angle O plus 90 plus 90 plus 60, okay? So O plus this plus this plus this will be equal to 360. Okay, so then what is O equal to? Well, we see 90 is 180. 60 plus 180 is 240. So O is equal to 120 degrees. And if O is equal to 120 degrees, so is right there. That is the worst arc drawing ever, but you see what I mean. Ln is also 120 degrees. And so how did that help us? Wait, sorry, my Windows is freaking out. One second. Okay, that should fix it. Okay. All right, so how did that help us? Well, we see if Ln is 120 degrees, right, what fraction of the entire circle is it? Right, it's 120 degrees out of a total of 360 degrees in a circle, right? So that means that Ln is 1/3 of the entire circle. And if Ln is 1/3 of the entire circle and the circumference is 96, right, then Ln must be 1/3 of 96. Okay, and what is 1/3 times 96? That's going to be equal to 32. All right. Okay. So 2 more problems left, and then I will address that system of equations problem. Hopefully my mouse started working better. Okay, sweet. All right. A botanist is cultivating a rare species of plant in a controlled environment, and currently has 3,000 of these plants. The population of the species that the botanist expects to grow next year can be estimated from the number of plants, and this year by the equation above. So this looks intimidating, but I don't want you to worry too much. It just kind of references n of next year and compares it to different, calculates using n of this year, okay? And what does K mean? K is the number of plants that the environment is able to support. Okay, so that's what K is. All right, so let's not get worried. Let's see what they ask us first. According to the formula, what will be the number of plants 2 years from now if K is equal to 4,000? So what is it going to be 2 years from now? So this equation really only tells us what it is next year based on what it is this year. So what I'm thinking is that we're going to have to actually do this equation twice, right? We're going to have to do it to find out how much is next year, and then we're going to have to take that value, plug it back in to the equation twice. So let's start. So n of next year is equal to n of this year, which is 3,000, right? Because currently they have 3,000. So 3,000 plus 0.2 times 3,000 times 1 minus 3,000 over 4,000, right? Because k in this problem is 4,000. All right, and we're going to have to do this twice, remember, because we want to find out not next year, but the year after that, right, in 2 years. So this is pretty easy as long as you remember PEMDAS, right? We want to do parentheses first, and then multiplication, and then we'll do addition last. So let's start right here. 1 minus 3,000 over 4,000. So what is 3,000 over 4,000? That looks really intimidating, but really you can knock out all of the zeros at the end, and it reduces down to 3/4. And what is 3/4 as a decimal? That is 0.75. So 1 minus 0.75 is going to be 0.25. And so now 0.25 times 0.2. Okay, so 0.2 times 3,000 times 0.25. Let's do that in the handy dandy calculator. So it's 0.2 times 3,000 times 0.25. So that's 150. Not bad. Oh, and so 150 plus 3,000 is going to be 3,150. So that is going to be next year, right? So now we have to use 3,150, plug that in for this year to find out the year after, okay? So now we're going to use 3,150 plus 0.2 times 3,150 times 1 minus 3,150 over 4,000, right? N doesn't change. So now we'll have to use our calculator. 3,150 divided by 4,000, 0.7875. Okay, and we're going to do 1 minus that. Okay, so it gave us a negative number because I did it backwards, but 1 minus that will be positive 0.2125. And we're just going to multiply that by 3,150 by 0.2, and we're going to add that to 3,150. All right, I'm sorry if it's a little boring. If you're watching this some other day, you can go on 2 times speed, but we're working through this with everybody in the live stream, so there are no mistakes, okay? So let's do 0.2125 times 3,150 times 0.2. And we're going to add that to 3,150. And so we're going to have 3,283.875, but it tells us to round to the nearest whole number. Okay, so the answer is going to be 3,284. Ooh. Is that what I have? Nice. All right, we got that answer? Sweet. So the last problem of test 2. It's almost over, man. All right, the botanist would like to increase the number of plants the environment can support so the population of the species will increase more rapidly. If the botanist's goal is that the number of plants will increase from 3,000 this year to 3,360 next year, how many plants must the modified environment support? So we see that K is how much it's able to support. So in our case, we want to use 3,000 for this year. Okay, 3,360 for next year, and that will help us find K. So we're going to plug in 3,360 for next year. And we're going to basically do this problem. All right, except this time we're not solving for next year, we're solving for K, which might present a few extra issues. Right, so our job really is to isolate K. We want to have K on one side and everything else on the other. So in this case, we're kind of going to go opposite of PEMDAS, right? We want to use our algebra skills now, and so we want to do the opposite to both sides. So let's start. What is the opposite? We're adding 3,000, subtract 3,000. Bam. So this is going to be canceled out, so we're going to have 360, okay, is equal to this right here, right? This entire thing right here. So how do we isolate this one parentheses, right? We want to get rid of 0.2 and 3,000. So what do? We divide them both on both sides, okay? We're going to divide this on both sides. So we're going to divide 0.2 times 3,000 on both sides. So on this side it cancels out, and then we're also going to divide it 0.2 times 3,000. What is 0.2 times 3,000? Okay, that's 600. Okay, so what is 360 divided by 600? 360 divided by 600 is equal to 0.6. That was easy. So 0.6 is equal to 1 minus 3,000 over K. All right, pretty good so far. Again, we want to do the opposite to both sides, so we want to subtract 1. All right, we're going to subtract 1, and we're going to get negative 0.4 is equal to negative 3,000 over K. And I want you to see, because we subtracted 1, we did not do anything to this negative. That's why we see negative 3,000 over K on the right side. And so now we want to isolate K, right? What we have right here is a little example of fractional algebra. And my favorite way of solving fractional algebra problems is to cross multiply. So we're going to change negative 0.4 into a fraction by putting it over 1. And you could put any whole number, any decimal over 1, and it would not change it. Okay, any number over 1, it's just itself. Okay, so this doesn't change anything. And so now we're going to cross multiply. We're going to multiply these and set it equal to this. Okay, so what is 1 times negative 3,000? Just negative 3,000. And what is K times negative 0.4? It's just negative 0.4 times K. That was easy enough. And so now the final step to isolate K is we're going to divide by negative 0.4 on both sides. Okay? And so now we see that 3,000 divided by 0.4 is 7,500. And if it's the same sign, if you're dividing the same sign, your answer will always be positive. Okay? Anytime you're dividing or multiplying by the same sign, two negatives or two positives, your answer will always be positive. Okay, so the answer is 7,500. Handy dandy notebook? Correct. All right, so this brings us to the end of the stream, at which point we will be doing viewer questions for the next, I would say 10 minutes or so. And I see, do I have any space? Oh, here, plenty of space here. I'll do it right here. Okay, and so we are going to work through Ashvith's problem, and it goes something like this: system of equations. So how come it's laggy on this? So it's not laggy on this one, but it is laggy on that one. Is it laggy on this one? No. Okay, I'm gonna figure out why that is, but let's do it. So we have 0.7a, okay, minus 0.8b is equal to negative 0.1. So that's our first equation. And our second equation is a minus 1.4 is equal to negative 6 times, that's a 6, by the way, negative 6 times b minus 0.1. Okay, so this is our system of equations, and it's pretty much done like any other system of equations problem. The only extra annoyance is that we're dealing with decimals. Okay, so we can still work through it with decimals just like we do with regular whole numbers, but maybe just to make it easier for ourselves, we'll multiply it by 10. Okay, we'll multiply both equations by 10 to move the decimal place over 1. Okay, so we're going to do that in a second. The first thing I want to do is distribute this -6, right? I don't want any parentheses kind of annoying us right now. So this left side does not change, and we're going to distribute -6. So -6b, and my 6's and my b's look very similar. -6 times -0.1 is equal to positive 0.6. Okay? And now what I want to do is bring the b to the left side and bring this 1.4 to the right side. So I have all of my variables on one side and all of my numbers on the other. Okay? So I'm going to add 6b on both sides here. I'm going to add 6b. And for now, by the way, I'm ignoring the very first equation. Just ignoring it for now. We'll come back into it once we set up the second equation how we want it. Okay? So now we have a plus 6b minus 1.4 is equal to 0.6. Okay? Let's add 1.4 on both sides. And so that way we will have all of the numbers on one side and all of the variables on the other side. So a plus 6b is equal, what is 1.4 plus 0.6? That's going to be equal to 2. All right, so now I have my equation set up the way I want it. Let's bring in that first equation. So 0.7a minus 0.8b is equal to negative 0.1. So again, you can deal with this just like any other system of equations problem, even though there's a decimal. But just to clean it up, and I want to teach you this technique, the easiest thing might be for us to multiply everything in this second equation by 10. And what that allows us to do is allows us to move the decimal place one place over. Okay? So we're going to multiply this entire equation by 10. Okay, and so what that allows us again, so it becomes 7a minus 8b is equal to negative 1. Okay, so that makes it a lot easier, right? And so now let me line up the two equations kind of in their final form. So we have 7a minus 8b equals negative 1. A plus, where'd it go? 6b is equal to 2. It is crazy how much my b's look like 6's. This is nuts. These are just like uglier forms of each other. I don't even know. This is 6b. Okay. So system equations, there's two main ways to solve it, either elimination or substitution. I'm just going to go into substitution today. I might make a video on elimination, actually both methods on a different day. So if you want that, please just let me know in the comments. But I'm just going to teach substitution today. So the way that we do substitution is that we want to isolate one of the variables. All right, so just have a on one side and put everything else on the other. And then we'll substitute in that a into the other equation. Okay, so you take one equation, isolate one of the variables, and then substitute it into the other one. So let's see how that works here. How do we isolate this a right here? Right, we want to subtract 6b on both sides. 6b. And so now a is equal, so this cancels out, 2 minus 6b. So why does that help us? Well, now we see that a is equal to 2 minus 6b. That means that this a is also equal to 2 minus 6b, right? Those a's are actually the same exact value. So if this a is 2 minus 6b, this a must be 2 minus 6b. And what that allows us to do is now replace 2 minus 6b. It allows us to substitute 2 minus 6b, okay, into that first equation. And the beauty of this is we now have a single equation with a single variable. instead of having two equations with two variables. Okay, that's really the goal. One equation, one variable. And so now we just solve it just like any other problem, right? Distribute the 7. 14 minus 42b minus 8b is equal to -1. Combine like terms, so 14 minus 50b is equal to -1. Okay, and now we'll subtract 14 on both sides. And so we see that, let me rewrite this up here. Let me create like a little pocket for it. So -50b is equal to -15. b is equal to -15 divided by -50. So what is -15? What is 15 divided by 50? b is equal to 0.3. All right, and again, this is positive, right? It's positive. So 0.3 is b. What is a equal to, right? Big question. What is a equal to? Well, if we know what b is, we can just plug in b, 0.3 for b and solve for a. So in this case, right, a is equal to 2 minus 6 times 0.3, right, because 0.3 is b. A is equal to 2 minus, I believe 6 times 0.3 is 1.8. And so A is equal to 0.2. All right, so the question asked, what is the value of the sum of A and B? So the sum of A and B is 0.5. All right, so Ashva, thank you very much for asking that problem. I love going into system of equations problem because they're so popular. And this light is very bright. How do I adjust that so I don't look like a ghost? Yep, you're totally welcome. Thank you for asking that. And again, if there are any questions in the comments or if there are any topics you're interested in, I understand not everybody's going to be taking the SATs. ACTs are becoming more popular now, and I actually like that test a lot, so I might go into ACTs. But whatever topic you guys are interested in, please let me know, and I will be sure to create a video on it or do a live stream. Actually, Ashfa asked a great question, wondering if you can get my email to ask more questions. What I actually suggest you do is you post it in the comments, because the goal of mine for this summer is to be answering all of these questions kind of in a public forum, right? So I think YouTube Live is perfect because a lot of high school students, most American high school students are on YouTube. So I'd rather ask that question for, 1 million people at once instead of just one person via email. So if you have a question, don't be shy and write it in the comments, and that way I can make a video on it and post it online. Okay, so I thank you very much for asking yours. My stream schedule is Sundays, Tuesdays, and Thursdays at 7 p.m. I apologize I wasn't here last Sunday, but going forward, I should be on Sundays, Tuesdays, and Thursdays, 7 p.m. Eastern to about 9 p.m. And I will be doing different topics throughout the summer. I'm starting with SATs. I'm thinking about different subjects to do later. Again, if there's any suggestions, please let me know. Comment on the video, write to me directly. And if you sub, I will be doing some hidden, sneaky subscriber sessions. So it will be completely unannounced. I'll just pop in and you'll get an email right away if I'm on, and you'll get to ask me questions in a pretty private forum, right? So it'll be you and probably like 3 other people for now. Okay, so yeah, just hit the sub button. It would help a lot. The goal is 20 by the end of July, and I think we can do that. Thank you guys very much for sticking with me for lesson 4. I will see you on Thursday, 7 p.m. Eastern for lesson 5, where I will be in test 3. So SAT Math test 3. Talk to you guys then.